Welcome back to Homework Help with Miss Gore. Today we're going to be talking about our Unit 10 Day 5 homework. We're talking about applications of quadratic functions. So the question says that we have profit P in dollars for manufacturing a wireless device given by the equation P of X equals negative 10x squared plus 758x minus 9,000. X is my selling price in dollars for each wireless device. So the first question is, what is the maximum profit the company will make? So I'm thinking about what this graph looks like. So if I'm thinking about what this looks like, I notice that my A value is negative. So I know that my parabola is going to be open downward and that I'm really looking for the maximum. I'm looking for the vertex. So what I can do is I first want to find the axis of symmetry. So the formula for finding axis of symmetry, x equals negative b over 2a. So I plug in negative 750 over 2 times negative 10. I calculate that and I get that my x value is 37.5. So I know that my selling price that I need, at what selling price will the maximum occur? Well, that's how I know my selling price. I know that my maximum selling price is $37.50. So if I'm looking for the maximum profit then, what I'm going to do is I'm going to take this, I'm going to plug it back in. So I really want P of 37.5, and that's going to give me my profit. So I've got negative 10 times 37.5 squared plus 750 times 37.5 minus 9,000. So my P of 37.5, so calculate there. I end up with 5,062.5. Okay, so in dollars, $5,062.50 is my max profit. So now answer it using the features of the graphing calculator. So all I have to do is enter this into my graphing calculator, graph it, and find me the vertex. We could use that by using the maximum function. Okay, you can kind of sketch that out on your graphing calculator. So the work that's leading to my answer for my maximum, the selling price, we already answered in part A. Okay, question 2. Using your graphing calculator, model the data in the table above, and it says to use a quadratic regression. So enter all of the data into the calculator, run a quadratic regression. I'm going to pause the video for a moment. We end up with negative 0.0001 x squared plus 0.05x plus 4.7. Now it says using my graphing calculator, determine the amount that would result in the maximum corn yield. So I could use my formula, x equals negative b over 2a, but it does say using my graphing calculator. So I will be looking for my maximum corn yield. So once I do that, I end up finding that I have a maximum point of 250 and 10.95. Okay, so just like I did before. And so I'm looking for the amount of fertilizer. So the amount of fertilizer I would need is 250, and this is kilograms per meter squared. Letter C, use the graphing calculator then to determine the maximum corn yield. Well, when we found our maximum point before, we have the maximum corn yield, but now be careful, this is in per 1,000 bushels. So this is 10,950 bushels. 10,950. Okay. Question 3. A small rocket is launched from the platform. The height of the rocket in h feet is represented by h of t equals negative 16t squared plus 64t plus 72. So I'm looking for how many seconds will it take the rocket to reach its maximum height. So first let's think about what might this look like. Okay, so we have it launched from a platform and we have it hitting the ground here. So when I'm asking for the maximum height, I'm really asking for the time that it's going to take to reach the vertex. I'm looking for the axis of symmetry. Okay, so my x equals, now in this case, since my variable is a t, I actually have a t equals negative 64 over 2 times negative 16. And I end up finding that t is 2 seconds. Now I want to know the maximum height. So I'm really looking for what is h of 2. So negative 16 times 2 squared plus 64 times 2 plus 72. My h of 2 is 136 feet. So now the question is, how long will it take to reach the ground? So if I'm looking for how long it's going to take to reach the ground, I'm looking for this point right here. So I'm essentially looking for one of my roots. Now, looking at this equation, I'm not really positive if this is a factorable equation, so I'm just going to jump in and try to use my quadratic formula. So t equals, let's see, so my negative b, negative 64, plus or minus the square root of b squared minus 4ac, all over 2a. Simplifying under the radical, negative 64 plus or minus the square root of 8,704, all over negative 32. All right, when I calculate this, I end up with two answers, but I only want the positive one. So I end up with 4.915475,947 seconds. Now it does not say to round this answer, so I'm not going to round it. I'm going to leave it. Okay, letter D. What does the constant term represent in the context of the problem? Well, the constant term 72 is our y-intercept. So the y-intercept then must be the height of the initial launch. Okay, letter E. What is the average rate of change of the rocket from t equals 3 to t equals 4? So when I say average rate of change, remember that we are looking for the slope. So I'm looking for the point. We had 3, and I'm using my graphing calculator. I'm just going to plug that in there. I get 120 and 472. So I'm going to use a slope formula. Okay, so my delta y over my delta x. So I've got 72 minus 120 over 4 minus 3. My rate of change is negative 48 feet per second. Now, indicate an appropriate domain for this model. So an appropriate domain, so where did I hit the ground? So I started at 0, and I landed on the ground when I got to about 5 seconds. Okay, if I want to be more specific, I could use that number specifically. And then letter G, check your answer with your graphing calculator. Hopefully that was helpful. Have a great day. Tell me that was recording.